It's learning time at Detailed Learning Online Institute for all secondary school classes. Come with me and let's talk mathematics. Waec, June 2014. Question 2 objective. So the question says, if 23 base x is equal to 32 base 5, it says find the value of x. Find the value of x. So this is exactly what the question says. Question 2 of Waec, June 2014. Now, taking a look at this question, since we can see that we have numbers, or we have a number in the base section of the right hand side, this is the right hand side and this is the left hand side of the equation. So we have a number or a digit in the base section, and we have an alphabet in the base section on the left hand side, but for the right hand side we have a digit. What comes to your mind? This should tell you that this question was drawn out from the topic number basis. Now, how do we approach or solve this question? First of all, we have to understand that numbers are written according to their number system. I said numbers are written according to their number system. We have several number systems which are also referred to as number bases, and I'll just mention some of them, maybe 2 or 3. We have the binary system, or the base 2 system. A lot of persons are familiar with that, and you are also familiar with that probably. Binary system is the base 2 system. Then we have the ternary system. This is the base 3 system. We have the quaternary. This is the base 4 system. And then we have the quinary. This is the base 5 system. We have the senary. The senary is the base 6 system, and so on and so forth. And then when we come to 10, we have decimal. Decimal is the base 10 system, and it happens that we usually operate the decimal system majorly, but when you come to concepts such as computer programming, then you find binary system in operation. Alright, so the number system is simply a manner of arrangement of numbers, a method of grouping numbers while trying to arrange them. We arrange numbers by actually grouping them. Let's take an example. If you are given a number such as 125, and this is in base 10, we call it 125 because we already know it's in base 10. Now, this number has been grouped. How was this number grouped? This number was grouped by grouping them in tens. So when we count 125, we break them into several places, and the places are as follows. Just watch these cycles. This is the first cycle, this is the second, and the third. So those are the 3 places that we have in the group. Now, the first place, which is this 5, that first place happens not to have up to 10 in a group. It doesn't have up to 10 in the group, so we just use this digit 0 to represent it. And the second place, which is 2, it has up to 10, but it occurs only once. So we have only one group of 10s there. And then in the 100 place, we have 2 groups of 10s. We have we have two groups of tens, two groups of tens in the hundred place. So that is why it's actually called 100. Okay, let me write it better for proper illustration. 1 2 5 base 10, here 0 1 and 2. Now for that reason we can call this part the 100, here the tens, and here the units. Again, why do we call it 100? Like I said, it has two groups of tens. Two groups of tens simply means 10 occurring how many times? Two times. And 10 times 10 is what? 100. So that is why we call this place the 100 place. The tens place has 10 occurring only once, and that is why we call it the tens place. And this other portion, the unit place, doesn't have up to 10, and it doesn't have up to 10, so we call it the what? We call it the unit place. So numbers they occur singularly, not, they are not in a group of 10. Any number in this unit place, they are not occur in a group of 10, they occur singularly or discretely, separately. So we call them units. All right, so having understood the number system, now it's also important for you to note that numbers have equivalents. According to their number system, they have equivalents. So if you're not writing in, if you're writing in base 10, if you're writing in base 10, base 10 is a higher number base compared to base 5. Compared to base 5, it's a higher number base compared to base 5, and base 5 is a higher number base compared to base 4. So if you say 125 base 10 is higher than 44 base 5 and 44 base 5 rather, and 23 base 4. So you can see it now that numbers have their values or their worth according to their number base. So if I am writing 125 base 10 and I'm also writing 125 base 6, these two numbers are not equal to each other at all. They are not equal to each other, although we are having 1 2 and 5 in both numbers, but because of their base, due to the values of their base, it has changed the worth or the value of the number. So these two numbers are not equal to each other. So I can therefore find a number that will be equivalent to 125 base 10. I can find a number that will be equivalent to 125 base 10 in another base. For example, or how do we do that? If you are asked to convert 125 base 10 to base 3, when you do that conversion, 125, if you want more classes on how to convert number base, just keep on following us at Detailed Learning Institute, and you will be able to have access to such classes. So converting this to base 3, 3 going into 12, 3 into 125 rather, 3 into 125 will give us, okay, let's take it bit by bit. 3 going into 12 will give us 4, and then 3 going into 5 will give us 1, and the remainder will be what? Will be 2. So we'll put it there. So again, 3 going into 41, so 3 into 4 gives us 1, remaining 1, adding 1 to this place. 3 into 11 gives us, so we're already writing it down already. So 3 into 11 gives us, 3 will go into 9 to give us 3, and it will be remaining 2. So we have 3, and the remainder again is 2. Now 3 into 13, remember 3 will go into 12 to give us 4, and the remainder is 1. So 3 into 4, 3 will go into 4 to give us 1, and the remainder is 1. Then finally 3 into 1 will not be able to go true, so we'll say 0 remaining 1 remaining 1. So the reason why we say it's remaining 1 is because you are trying to divide 1 by 3, and then we say it's not going, it can't work because it's giving us a fraction and we don't want fraction. So we just simply say, well, since we don't want fraction, we couldn't divide, so our answer is still 0. We don't have anything as our answer, but we are having something left. That one which was not divided still stays there as a remainder because it wasn't divided after all. Is that so? That's why we say we are having 1 here as a remainder. Okay, so in that case, what becomes the result of our conversion? The result of our conversion becomes what? We draw an arrow and we read from bottom to the top so that our answer becomes 1 1 1 2 2 base what? Base 3. So you can see that the actual equivalent of 125 base 10 is what? Is this 11122 base 3. So you can see how many digits we have here. We have 1 2 3 4 5 digits, and over here we're just having 3 digits, 1 2 3 digits, yet this number is actually equal to this number. You see it? So we can have numbers equivalent to each other on the basis of their what? Number base. On the basis of their what? Number base. Numbers can be equivalent to each other on the basis of their what? Number base. Yes, on the ground of their number base, depending on their number base. All right, so in that case, let's go back to the question that Waec asked in 2014 June exam, objective question 2. It says if 23 base s equals 32 base 5. Another word we can use to replace that equals, we'll call it equivalent. If 23 base s is equivalent to what? 32 base 5. Find x. So this has already told us that actually there is an equivalence, meaning 23 base s is the same thing as 32 base 5. The only difference is that they cannot be in the same base. They can't be in the same base. They are equivalent. Yes, we agree. They are equal to each other, as we have just proved that numbers can be equivalent to each other, even if they are having different digits. But they must be in different bases. So they are equivalent to each other, but they are in different bases. So how do we find out the new base, the base for x, what x is, what value x actually is? The way to find it is that we are going to transform each of these numbers. That is, we're going to transform 32 in base 5. We're going to transform it to its base 10 form. We're going to transform it to its base 10 form. And then we're also going to do the same for 23 base s. We're also going to transform it to its base 10 form. Yes. Because when we succeed to do that, if we can transform 32 base 5 to its base 10 form, and as well transform 23 base s to its base 10 form, then we will now actually get the equivalent of these two numbers in base 10. And if we can get the two numbers in base 10 is like a general number base system after all. Then if 32 base 5 is converted to base 10, if it's converted to base 10, when we also convert 23 base s to base 10, we should get the same thing. Do you understand that simple logic? Yes, if we are saying 23 base s is equivalent to 32 base 5, that means if I convert 32 base 5 to base 10, I should get a value. That I should also get when I convert 23 base s to base 10, because after all, both of them are equivalent to each other. So at the end of the day, I should also get the same value that will be here when I convert 23 base s to base 10, because both of them are said to be what? Equal to each other. Exactly. So for that reason, for us to be able to find what s is, we are going to convert both of them to base 10. Alright, so doing the conversion, let us start from 32 base 5. So to convert a number from from that base 5 to base 10, we are going to expand it in the multiples of the base to powers. Multiples of base to powers. How do I mean? You are going to arrange the number first of all like this: 32 base 5, and then you attach powers to the digits beginning from the very first digit by the right. You put 0 there, the next one takes 1. If there are other digits, they will take 2, 3, so on and so forth. But since we are having just 3 and 2, so they will take just 0 and 1. Then we'll now expand this in multiples of the base to powers. So multiples meaning we'll start from the very first digit here, 3 multiple of the base to the power that was present in that 3, which is what 1. Then we'll add it to taking 2 now, 2 multiple of what the base, which is 5, to the power that was present on 2, which is 0. So eventually we'll just do the arithmetic, and this will give us 15 plus what 5 raised to the power of 0 is 1, because anything that is raised to the power of 0 will always give 1. So 2 times 1 will result in what 2. So 15 plus 2, and this will give us 17 base 10. So you can see what we are talking about. 32 base 5 is equivalent to what 17 base 10. Now when I convert 23 base x to base 10, it should also give me 17 base 10. Yes, I can say that. Yes, because we are told that 23 base s is equal to 32 base 5. So if 32 base 5 is 17 base 10, then 23 base s should also be equal to 17 base 10. So I can say 23 base x is equals to what 17 base 10. 17 base 10. So it's not left for me to convert this 23 base s to base 10, and I will do it the same way. Just attach powers 0 and 1, and then you expand it in multiples of the base to powers. So the first digit is 2. We'll take that, attach a multiple sign, then you put the base x. The power present on 2 is what 1, plus go to the next digit, which is 3, attach a multiple sign, put the base. The power present on 3 is what 0. This will be equal to 17. So we decide to leave the base 10 now. We don't want to write it, since we already know that we are working in base 10 now, because we have converted to base 10 already. So 2 times x, do the arithmetic again. This will give you 2x, simply because x raised to the power of 1 is x. Now plus 3 times this, s raised to the power of 0 will still be equal to 1. So 3 times 1 is what 3, and this will give us equal to 17. So you can see now we now have a simple equation before us, and we'll simply collect like terms. Collecting like terms meaning placing the term that has the unknown, which is also called the variable, and that is this variable alphabet, on one side, while we place the digits on one side. So simply doing that, we have to move 3 over to this side, and when that happens, the sign attached to 3 has to change, and this is the sign attached to 3. The sign attached to 3, which is positive, has to change to negative. So we'll do the movement. So we'll be having 2x equals to 17 minus, it has changed to minus 3, and then we'll do the arithmetic. We'll have 2x is equal to 17 minus 3 is 14. Yes, so at this point we're about to get s, but we see that there is still a 2 attached to s, and we must remove it. So for you to remove it, you do what we call divide both sides. Divide both sides by the coefficients. dividing both sides by the coefficient of s. Hope you understand what coefficient means. For those of you who don't understand what coefficient means, coefficient is simply the digit that is attached to the variable in an equation. So the variable is the alphabet, so any digit attached to a variable is called coefficient. Now if we are dividing both sides by the coefficient of s, it means we are going to divide both sides by 2. So dividing both sides by 2, we have 2x over 2 is equal to 14 over 2. Now simply stroke out or cancel out. 2 into 14 will give us 7. Now we are left with x over here. We cannot say therefore x is equal to 7. And if you check your past question very well, that happens to be option A. So that's how to solve that particular question. So with this video lecture, I believe you have understood properly the concept of number based system, and then you have understood the fact that several numbers can be equivalent or equal to each other even though they are actually having different digits, as long as they are in different bases. Then you have also seen how to convert a number from base 10 to another base. For example, converting 125 base 10 to base 3, and then you have also seen how to convert a number from another base such as base 5 to base 10, which we did over here, and then we went ahead to resolve that question and got our answer as 7. So once again, this is Detailed Learning Institute, our Telegram group classes. So this is a sample video. If you are in secondary school, GSS1, GSS2, GSS3, or SS1, SS2, SS3, you can do where to search for Detailed Learning Institute on your Telegram app. Join the group to receive more classes like this and get information on how you could receive detailed lectures for what you are taught in school as a student. If you're a parent who have just watched this video, share to your children and your loved ones who are in secondary school and help them to utilize their phone for getting knowledge that is going to be useful to their future. Thank you very much.